In today's video, we're going to be designing Slack, but with a subtle twist. It's going to be an MVP version and a minimum viable product, something that can be done in a couple of weeks. This is commonly asked in big tech, especially OpenAI. So we're going to be going through the requirements gathering, any relevant estimation we need, back of the envelope calculations, entity layout, the API, high level design, justification for decisions, and I'll be showing you what to deep dive into. So definitely, watch till the end. Obviously, if you find a section of the video something you're familiar with and you feel like skipping ahead, feel free to do so and jump to the sections that suit your knowledge gaps. This is on the conditioning website, so we have the problem description here, but we also have like a full thought process based explanation here, which you can always check out. But what I'm going to do in this video is just do a tutorial style walkthrough. What we have here is something more like it's like a transcript between an ideal candidate aiming for a strong hire and the interviewer. There's also a tutor voice just to clarify things. So it's something that you should be able to read from first line to the end and not get lost because everything is clarified. In case you're wondering how to get here, obviously you can have a look at this URL, but we do have, if you go to the conditioning site in our learning section, so conditioning/app/learning, or if you just hit the learn button in the nav bar, it'll take you here. You go to OpenAI software engineering course, and in the system design section, you find this design Slack problem. So that's how we get here. Now back to the problem. I bet most of you listening have used Slack or something similar, but it makes sense for me to just do a quick overview of some key concepts. I'll be very quick. So you can imagine an interface that looks like this, and you can be a certain channel. Let's say you work in a company and there's, I guess, the channel for engineers, maybe software engineers, and everyone maybe in a certain team, and everyone can post a message, everyone can see, people can respond to each other. And when you have a specific message, this can maybe be something that deserves its own thread. It's like maybe deviating from the main conversation going on in the core channel, or it's like just a special topic that maybe just needs a few people to dive into, or it's like going on a tangent or whatever. So the idea of a thread is it's a spin-off from a core message. This core message would you consider as a root message, and then all replies will now be in this thread sort of view, and you wouldn't see it in the core view for the channel. Obviously, anyone that wants to see the thread can click the view thread button and then go off and see. If you use Discord, you're probably familiar with the concept of thread as well. And of course, direct messages, everyone's familiar with that, one-to-one messaging. So I just wanted to get that out of the way. So if you had to solve this in an interview, you would, or I would recommend that the first step you do is you start gathering requirements. And to do that, you probably need to ask some clarifying questions. Some people struggle with requirements gathering. So what's a good sort of mental model for you to think about what the requirements you might need would be? And I would recommend just thinking about the users of the application and the kind of interactions they would have, like workflows. So for example, and maybe not just users as well, just any sort of, I'll use this term agent involved in any sort of interaction. Or let's think of workflows. So one workflow could be user A wants to send a message to user B, like a direct message, or user A wants to send a message to the channel, and so on. So that kind of thinking would help you think about the requirements that you need. And then of course you can start thinking of how things could go wrong as well. That would also help. So something that just gets better with practice. The two core types of requirements we care about: functional requirements and non-functional requirements. Functional requirements, let's gather them like we would in an interview. So I would always recommend you literally have a section for functional requirements and you list them out one by one. Because you're in an interview scenario where you're very time constrained, you aren't actually doing a design like you would if you were, at your desk at your job and trying to actually build something you're going to deploy. It's an interview, right? So it's a microcosm of a real thing. So you can't go off and do everything. So you need some kind of prioritization mechanism. I would strongly recommend doing something like this. So you can have these three keys: must do, should do, and nice to do, or we can call it optional. So a must do is something that's very critical to the design. for whatever you're designing, like this is such a core functionality that without it, the app doesn't work or the system doesn't work. It should do is something that, and I'm defining these, right? It's something that, yes, if I was actually doing the real design, I would do this, but because it's an interview, I could probably get away with not doing this. It still should be mentioned. This is just a classification mechanism to tag things. And then nice to do or nice to have is something that, I think the name is self-explanatory. So what you probably would shoot for is to at least cover all the must-dos. And if time allows, you can cover the should-dos, and, the nice to do's, you could probably just mention them. So I would always recommend, using this classification and writing things down. I already have gathered their functional requirements, but you should definitely, have them all listed out in your interview, because this is pretty much a contract you're signing with the interviewer. You're going to check with the interviewer, like, are you happy with these requirements before you go off and start doing your design? So let's have a look at the requirement. In this guide, it's actually depicted like a conversation, between the candidates and interview, and the kind of questions that the candidate would ask. So here, with the candidate is asking who the primary users are. I think if you're ever blanking out in an interview when you're trying to gather requirements, that's like a good first question to ask, because then you know who you're building the product for, who's actually going to use it, before you can then think of what features they need whilst they're using it, right? So the interview is here saying it's a corporate team, and I'm just going to skip a lot of these things, although this one's actually useful, where the candidate is trying to see if there could be multiple like teams using this MVP. So for example, it's an MVP, it's not a full-fledged app. So is this just one team which will have their own workspace that are using it? So it could be multiple teams. So if we pick OpenAI, for example, they have a Sora team. I'm making this up, by the way. Sora team who deal with image generation. There could be a team that deals with speech to text. There could be a team that deals with the Chat GPT app. There could be a team that deals with the APIs, teams that, work on research for the next generation of models and so on. So each team could probably have its own workspace, and we can ask if for the MVP, are we just doing something very simple for just one team, keep it simple, one workspace, or do we have multiple teams? So let's look at the requirements we actually came up with. So the most intuitive one is we think of a single user, right? A user should be able to send and receive private one-to-one messages with any other member of their workspace. Private is actually a keyword, because if person A is having a conversation with person B, we expect this to be private. Someone else shouldn't be able to see it. So if I'm saying something not so nice about another member of my team, maybe my manager, I don't want my manager to see that. So that's just one example of a lot of people will be able to relate to. The next key requirement is that, I'm just going to start from the top. The system must allow the creation of isolated workspaces. So workspace admins must be able to create and archive channels. The whole idea here is there's some level of isolation. So for example, the team that works on models have a lot of proprietary research information, and they might just want to keep these things between them if they have something new and they don't want things to leak, right? So they can keep their channels and just all their messages private from other workspaces, other teams. So that isolation is actually very important. There's this concept of channels where users should be able to create different channels. So there could be a channel for different types of conversations. There could be a channel like focused on important projects that are being worked on. There could be a channel for like banter amongst team members. I mean, if anyone's used Slack in certain organizations, you probably had this, a channel for memes or whatever. Talked about the direct messaging. I think it's definitely important to specify that a user must be able to send and receive and read messages in channels, and they should be able to fetch message history. Specifying this pagination isn't necessarily required, but the idea is you should be able to look at messages you've sent or messages that have been sent by other people in the channel you belong to. So being able to view the history. Threads is also another concept where users must be able to, so we spoke about threads just at the start. So users must be able to reply to any channel message and create a thread if they want, or view the threads, right? Read thread replies. And a channel may have many threads. So these are all grouped under threads. So we already have 5 requirements, which is quite a lot so far, but they're all sort of intuitive and related. Okay, we have one about file upload. So if we think about the user base, we mentioned they were corporate users. You can imagine you're using this as part of their day-to-day work. So you can imagine them having to share files with each other, where it's like a presentation or an image or a document, documentation about something or whatever. So file uploads definitely seems like something that at least for an MVP, for this to be useful, might be something we would have. Some could argue this should be a should do, and it could be in the next iteration. So maybe you can agree with this, your interviewer, and whether they want to see this. But so I think file uploads are quite core. So I'll at least try to include it. The only cap I'll do is because it's an MVP, I'll put a limit on file sizes, but a very small limit. So I'll just limit it to like 50 megabytes or maybe even something smaller. And I'd also put a limitation on how the length of time where files are accessible. So you're going to limit to 30 days. Again, it's an MVP. And the reason I'm doing this to make sure I don't have a big headache when it comes to file storage. If I'm storing a lot of files for a long time, the data requirement is going to be quite big. Obviously, this is going to be something to do in the real app, but for an MVP, I'm just putting these limitations to make life easier. One thing that'll be important to make clear to your interviewer is whether you're building a mobile app, desktop app, browser app, all of the three or subset of the three. Obviously, because it's an MVP, it makes sense to just pick one. I wouldn't do a mobile app because it's corporate users. Between desktop and browser, I'll pick a browser-based application because I know that then, regardless of whether users are on a MacBook or a Windows machine, they can actually still use this MVP versus if I had to do a desktop app where I then have to build for different operating systems. Obviously, we have AI enabled coding these days, so it can make things easier, but let's keep it simple. Let's keep it to one. Let's do a browser app. So the next requirement is about notifications. If I send someone a message and they're not at their desk, it makes sense that they at least get a notification. So when they come back, they at least see, oh, I received a message or reply or a mention. So that's the next requirement about notifications. The system must display notifications to users in the web app for mentions, replies, any message to receive. I'm going to keep going. Email notifications is something that I'm definitely not going to cover in this design. If you already have the in-app notification, that's nice. Email notification could be useful. Maybe if someone's away and away from the desk, and maybe they can get an email notification about an important message. Maybe someone's on a sales call or something. So it's like a should do, something we'll do if we were doing the real MVP, but for the purpose of this interview, maybe something we might not get a chance to talk about. But they're definitely important. And I think it's nice to have these nice UX features like reactions, type indicators, someone's like typing a message, have that read receipts. Is someone online or offline? I'll probably argue this probably should be a should do, but we can also push it in the nice to do. If someone's offline, then I guess they'll respond when they do for the purpose of the MVP. So all these kind of enhancements, this nice extra polish, they're obviously useful, but they're just nice to have, right? So those are all functional requirements, just talking about the behavior of the system. Hopefully these feel intuitive to you. So what I've done now in terms of the functional requirements is express them in a very abridged form. This is how you would do it in an interview. You're not going to write like super long sentences that will take all the time. So just to pick an example, functional requirement 3 just says one-to-one direct messaging. So we're talking about, a user should be able to send messages to another user privately. So maybe I could just include the word private, because that's the keyword. Also, in terms of classification, I've decided to represent must do's with an M, should do's with an S, nice to haves or nice to do's with an N, right? Again, because in an interview, you'd be managing time. So now that we're done with the function requirements, we can move on to the non-functional requirements, which just define how well the system does whatever it does, right? So functional requirements about what are the functionalities of the system? What does it do? The non-functional tells us how well it does what it does. So let's go to them in turn. So the key things we'd probably be looking at in an interview, depending on the system, some are usually always relevant to any problem, but some may not be so relevant. Availability, the latency, the durability, the security concerns, observability. Those are the ones we'll be going through. So the first one I'm going to go through is availability. And for those who don't know, the availability is just telling you the proportion of time a system is up and running. This table you see here summarizes useful numbers that you should know when it comes to availability. Now, I'm not saying you should memorize all these numbers to the decimal places, but from an availability perspective, if you're designing systems, you're typically going from 99%, which is two nines, 99.9% availability, three nines, four nines, five nines, going up to, I think the last one is seven nines, right? So the downtime per year each one corresponds to is shown in this column. The downtime per month each one corresponds to is also shown here. And this just gives you a feel for like how available your system is, right? So for a 99% available system, we're expecting roughly 4 days of downtime per year. I don't know what system I'll design that's acceptable. Maybe for an MVP product that's only going to be used by few internal users that know that it's an MVP, maybe that could be tolerated. Three nines is roughly 9 hours. But what you basically notice is from four nines, you see 52.6, then it becomes 5.26. So that, I guess for these two, it's easy to remember. You just, for an extra nine, you move the decimal place once, and same thing is happening here. Similar thing happening here. So this might help. So you could just round up the numbers and remember some key ones, maybe three nines, five nines, 11 nines, and you can have a good ballpark estimate of these things, at least for the downtime per year. The downtime per month you may not memorize, or it's something you can easily calculate. Okay, so for this MVP system, which we are designing, I decided to opt for what I consider is the minimal tolerable availability, because if I start choosing high numbers, I then have to have redundant databases. I need to have multi-region failover. Okay, some of my infrastructure in North America, in Europe, and so on and so forth, different regions, and that's just overly complex work for an MVP. So what's the minimum availability I can get away with? I'm looking at the downtime per month table. If this MVP is down for less than an hour in any given month, let's say worst case, there's a 45-minute period where it's down, that still seems acceptable. I'm just going to go with that for the MVP. Non-function requirement, let's talk about latency. So I have a table here for you, just to give you an intuitive feel for what different latencies look like. I think it's a good thing to, this is some good numbers to know as well. Learn them in sort of in an intuitive way. I wouldn't say memorize them. You kind of just want to have an intuitive feel for them. So just like blindly memorize them is kind of what I mean. Obviously, everyone knows what a minute feels like, but when it comes to like smaller numbers, it's not so intuitive to us. So I'll say in the context of a messaging app where we're sending messages, receiving messages, if something is taking over a second, so if I send a message, it's taking more than a second, let's say it's taking 10 seconds, for example, we obviously know those are too long. 10 seconds too long, a minute's too long. A millisecond for a human is something very imperceptible. Even 0.1 millisecond, these are, if for all intents and purposes, these are effectively instantaneous. So that's on the extreme. A second is probably on the high end of what's okay. So anything, and then 10 milliseconds feels instant to users. So anything in the 10 millisecond to 1 second range, I would say, is ideal. So you can put a number in that range. So as a candidate aiming for a strong hire, the way you're going to express your non-functional requirement for latency is to say, you know what? I mean, one good way to do so is to say, look, 99% of requests are going to have a latency that's underneath 200 milliseconds, for example, right? We can't necessarily guarantee, that latencies will be this constant number or would never exceed this range, because there's things that happen in our system that are outside our control. You can have some program running and the garbage collection runs and introduces some delays. You can have cache misses. You can have excessive traffic at certain moments in time that mean messages wait longer in queues. So all network jitter, right? The network latency is not always perfectly constant. So we can't control all these things, but if we can design our system where 99% of users or 99% of requests would fall under an acceptable range, I think that's good enough. So that's how I would express it. Like the P99 target for latency for sending messages is, we can say 200 milliseconds and lower. That's what I have here. We also decided to specify latency targets for thread fetches. So it's one thing to just get a single message, but it's another thing to get all the messages in the thread. I just put something a little higher, but at the end of the day, they're just all in this 10 millisecond to a second range. I don't want to be too aggressive in latency and go for these really low numbers, because then I have a lot of work to justify how I actually achieve such numbers, and we don't even need them for an MVP. The next non-functional requirement we're going to cover is durability. So in this system, we have a situation, or in a system where users are sharing messages, sending and receiving, sharing files. This is all data that, if they log off their system and come back to, they want to be able to see this information persisted, right? But of course, we're also designing an MVP. So how durable should the system be? The obvious answer is we shouldn't lose any data. But because it's an MVP, we don't have to be that aggressive. The more aggressive we are, the more work we have to do to justify things, the more expensive infrastructure becomes, or the complexity usually translates to that. So because it's an MVP, I'm just going to ask myself, what time period worth of data is tolerable? So let's say in the worst catastrophic failure, I think a minute worth of data is tolerable. So if users using the system and all of a sudden the last 1 minute of data is lost, the last 1 minute of messages, maybe users have sent between 1 to 3 messages in that time period, can they easily recover from that? I think a minute is aggressive. So there's this idea of a recovery point objective. If the RPO was 0, I'll be saying that my system spec is that no committed data should be lost. If I say it's a minute, I'm saying in the worst case, up to 1 minute of writes could be lost. This doesn't mean my system might not end up being an RPO equals 0 system. It's just that I don't want to be too aggressive because of an MVP. So this is fairly durable, good enough for an MVP. So let's move on to the next non-functional requirement. Security is definitely, it's obviously very important in a system like this. As a user, I shouldn't be able to see messages between, like private direct messages between other users, right? I'm not in that conversation. I can see messages in the channels or workspaces I belong to, but if I'm not in the frontier research model, team, I shouldn't be able to see any of the messages there. So there's definitely that isolation that needs to happen, and authentication and authorization when it comes to determining who can see what. So there's that level of security for sure. And of course, if this is a corporate context, there's a lot of private corporate information. There could be non-public material information that shouldn't leak. All these things need to be secure. So, hackers shouldn't be able to come in and break through and access this information very easily. So we have to, encrypt messages, store them securely, and of course prevent abuse, like denial of service attacks and so on. So we should have rate limiting and so on. So all this standard core security practices are definitely things we should employ. That's the fourth non-functional requirement. And the last one is just observability. Again, for the MVP, we ask ourselves, do we need to be able to track metrics and alerts related to what's going on in the system? Of course, because we still need to maintain it. If users are actually sending messages and receiving and they have issues, having logs, having metrics, having alerts, being able to monitor the latencies, and just general performance of the system will help us improve it even during the MVP phase. So I'll say this is a should do, because this isn't like a core functionality that we can't do without, but it's definitely something we would do in a real system, even though it's an MVP. And there's going to be a lot of off-the-shelf solutions for achieving this. So we don't have to talk too much about this in the design. The last core non-functional requirement we're going to cover today is scalability. And I already have some numbers here, but in an interview, you would either infer some of these or request some of these from the interviewer. So in this case, I would want to know, okay, I have corporate users, but what's the worst case number of users? What's the maximum concurrent users or, my app at any given time? So if the interview tells me it's 5,000 users and maybe they agree that 8,000 concurrent users, max concurrent users is reasonable for whatever our use case is, depending on whatever the users might be doing. Maybe a lot of them are sales users, so they're always sort of maybe this is an organization where people are in a lot of meetings. Maybe for some reason, less than half of people are, in the worst case, using this messaging system, especially for this MVP scenario, right? So maybe 1,000 is fine. So if that's acceptable, that's great. If it's not, we could probably, raise the number. So just working with 1,000 max concurrent users, if all these users are, let's say, sending, so let's think about it. Let me push things to extreme. If they're sending 2 messages every, let's just say 30 messages an hour. So every 2 minutes, someone sends a message. So I'm actually focusing on an individual user. So if every 2 minutes, I should do that somewhere. If every 2 minutes someone sends one message, then in 60 minutes, which is 30 times this, they will send 30 times one message, so 30 messages. So if I have 1,000 concurrent users, and let's say they're all behaving in this sort of worst case way where every hour, every 60 minutes, sending 30 messages, that is 30 times 1,000 messages per hour. I'm going to call that MPH. So that's 30K messages per hour. And on a per minute basis, so it's 30K messages an hour. There's 60 minutes in an hour. So 30K divided by 60. If I cancel the zeros, I'm just doing division. Well, 30K divided by 60, that gives me 500 messages per minute. So that's kind of what we're aiming for from the perspective of message sending from a scalability perspective. I think for file uploads, we did speak about there being a cap on the max file size, but we can also ask ourselves, well, if these are the maximum number of concurrent users and there's a cap on the files sent per message, well, if we have 500 messages per minute, it's not too difficult to work out what's the worst case sort of max amount of data being transferred from the file's perspective. So just in terms of file transfer data, the pressure on our system that comes from that, if we have 500 messages per minute, and let's just say for each message, it utilizes the worst case file size or file data of 50 megabytes we set. So in a minute, there's 500 messages, and for each of these 500 messages, let's say there's 50 MB of data from files. So that's 25,000 megabytes per minute being transferred from a file perspective, and that's 25 gigabytes, sorry, per minute. So this is a very worst case scenario because, obviously in every single message, some of these messages, no file is going to be like transferred, right? So, but this is just an upper bound just to see how our system can handle this. So from a scalability perspective, there's messages being transferred, there's files being transferred, and we have some, at least quantification of what we are designing against. So far, I've covered about 6 non-function requirements, which I consider core, but I have another table for you. Here, it shows something you can essentially use as it's almost like a framework in terms of when you're working on non-function requirements. So you can essentially have this list with you and just go through each of them and see which ones are relevant for your system. Usually all of them, most of them are. Some might not be so important that you spend too much time on. So we've obviously gone through performance, with latency, gone through availability, scalability, security. On consistency, what I'll just say is this is clearly going to be a very real-time system, so very low latency. So in some ways, I've covered that. Some people like to think of CAP theorem and doing the trade-offs between availability and consistency. I don't really want to do that here. When I get to specific parts of the system where I have data, and this data is stored in database or some cache, I can then start maybe talking about whether I want eventual consistency or strong consistency, or maybe I'm talking about certain workflows. I might decide, okay, I want read after write consistency or something else. So all I'm just going to say on this point is users aren't really going to be seeing stale data because it's going to be a very real-time system, except for a situation where we have a data loss, and on the durability point, we agreed that worst case, we lose 1 minute of data. Fault tolerance, definitely important for sure. So what I would say on that is our system should be fault tolerant. And I haven't really thought through, at this point, I'm just gathering requirements of these specific faults that could happen. When I maybe start exploring my design a bit further, I can start highlighting some of these ways my system could be fault tolerant. I guess one example here, it's an obvious one, right? If we're trying to send a message through and maybe something goes wrong in the backend, maybe it's user A is trying to send a message to user B and I'm trying to store that record in database. Actually, a step back. Maybe a better example might be maybe a notification, right? So user A sends a message to user B should get a notification, and our system is trying to send a notification and there's a failure for any reason. We will have a mechanism to replay or retry sending the notification. So that's an example of fault tolerance. I'm sure there'll be more of these, so we can highlight them during design. We spoke about observability. Cost efficiency is not really something I want to spend time doing like estimates for in an interview sort of design. So I could just say, it'll be cost efficient, but it's an MVP. Compliance, again, of course, we're storing data. So there are definitely a lot of compliance related requirements. But in an interview, I'm not going to start gathering like regulatory requirements on retention and so on. I'm just going to say my system would comply with all these things. Again, for the purpose of an interview, I'm not going to spend time on these things. But this is a good table to have, or even if you don't want a whole table, just this list of things that you can run through in an interview. The first four, if you look at just the first characters, PASS, that sort of gives pass. You want to pass your interview. So maybe that helps you remember these four. For the others, I guess you just have to figure out a way to remember them. Obviously, with practice, these things become second nature. So here we have our non-functional requirements, and I've expressed them how I would in an interview, just in this concise, form. So I'm not writing super long sentences. Okay. So here we have our functional requirements, our non-functional requirements. At this point, though, you would want to check with the interviewer, ask them, have I captured requirements accurately? Does this look like a system that satisfies what you're looking for? And if they have, ask them if they have any objections. If they have no objections, then you can proceed. The worst thing you can do is start designing against the wrong set of requirements. Then you get to the end of the interview, and the interviewer says like, "This isn't what I wanted," right? So definitely always check with the interviewer to make sure they also sign off on the requirements before you proceed. So let's go through our core entities, the first class entities for our system, our design. I'll explain what I mean by first class shortly, but everything starts with a workspace. It's a key. I can think of it like a containment that isolates, different teams. A workspace will have an ID, and we have a user. A user can belong to one or more workspaces. So user is another core entity. A user sends messages and so on and so forth. Then we have this idea of a channel, which is just essentially a group conversation, as opposed to a direct message conversation, which is a one-to-one private conversation. So a user can send a message within a channel, so group conversation, or send a message within a direct message conversation, so one-to-one private combo. Of course, message is a core entity. Users send messages within channels or DM conversations, which all belong to workspaces. And if user A sends a message to user B will get a notification. So there's this core concept of a notification. And of course, we also mentioned we support file uploads. So I'm not going to call this file, I'm going to call this file metadata, because when I'm storing my files, like in my data stores, I'll be having things like the file name, the file size, when it was created, or when it was uploaded, and all these kind of information. So it's more about metadata, and I may end up storing my file in some separate data store. But we're just focusing on entities. So these are the core entities, and you might be wondering, why are these the entities? Maybe you had some other entities in your list. Maybe someone, like I've been asked before, like why is a role not an entity? And by role, I mean a user could be an admin, could be just a regular user, so non-admin, and maybe who knows what other roles we could add. So these are a bunch of questions that you can quickly ask yourself to see if something qualifies as a first-class entity. If the answer to most of these questions is yes, then it probably is an entity. So it's not like like a foolproof exact rule. But intuitively, usually you can tell. So can this thing have an ID? So if you can usually have multiple instances of this thing, that's probably a good sign that it's an entity. Does it have attributes or properties? For example, a user will have a name, a workspace will have a name, so that's an attribute. A workspace will have the time it was created at, so it makes it an attribute. A user will have an email, will have a password, display name, avatar, so it has an attribute. Lifecycle, so can this thing be created, updated, deleted? So basically CRUD operations, if you can do them on it, it's probably an entity. And does it have relationships to other things or to other entities? So for example, a user belongs to a workspace, can belong to a channel, can belong to a DM conversation, can send a message, can receive notifications, right? So if you can, in answer to most of this is yes, then whatever you have is an entity. So what we're going to look at next is the API. So for our service, of course, our system rather, we obviously have a user interface. We've decided to go with a browser, but there's got to be a backend service to facilitate all the interactions. And for this, we need an interface. This is where the browser will send requests to. And in the future, when we have mobile apps and desktop applications beyond the MVP, they'll also be reusing the same backend. Now let's walk through the backend API. I've laid out a couple of endpoints, and I've been very intentional to only choose endpoints that I deem suitable for the minimal viable product. This reduces the amount of work we have to do. So the first batch of endpoints are workspaces. By the way, I've decided to go with a RESTful API. And really the reason for this is it just maps naturally to what we're trying to do. The operations we really need are mostly CRUD operations: create, read, update, delete. These are the kind of things we need. And our entities map nicely as resources. So our endpoint is resource oriented, which is really what REST is about. And then the rest is simple, it's well understood. So that's why I've gone with this versus other frameworks, or other architectures and frameworks like SOAP or remote procedure calls or even GraphQL, which will just add unnecessary complexity. So the first set of endpoint pertain to the workspaces. Obviously, for an MVP, we need to be able to create a workspace. We need to be able to add members to a workspace. So this endpoint says, well, the resource or the collection here is members within a specific workspace. So the post allows us to add a user to this workspace. I haven't obviously shown the payload just to save time. If the interviewer were to press me on that, I would, but it would take too much valuable time to show all the request and response payloads for all the endpoints. So I would always recommend trying to do a high level layout, unless it's like a product oriented sort of interview where, okay, the big part of your design is the API, then you can sort of dive deeper. The next endpoint is a patch, and this is being able to update a specific user within a specific workspace. So you want to remove a user, you might want to update their roles, make someone an admin, maybe someone leaves or something. So I feel that that's critical for the MVP. And then we have this concept of channels within a workspace, so channels within a specific workspace, right? Within our workspaces collection. So imagine the app is loading, it should be able to fetch the channels in a given workspace that a user belongs to. Of course, users should be able to create channels so they can have these group conversations. That's what the post on this endpoint is for. So you're creating a channel within the channels collection within a specific workspace. Then of course, direct messages. Now let's look at the direct message endpoint. So think of a user opening, Slack app on a browser. They would want to be able to see what direct messages they're currently involved with. So I have this direct message with my manager, with this colleague, with that product manager, and so on. So that this being able to fetch direct messages within a certain workspace is going to be useful. Also being able to create a direct message within a certain workspace. So same endpoints for these first two. Same paths for the first two. In terms of the next set of direct message related endpoints, so a user might want to, so for a specific direct message, so that's why we have this DM ID, again, within the direct messages collection, within a specific workspace, they want to fetch all the messages within that direct message. So when I open a specific conversation I have with my manager, I want to see the message history, right? This is probably something that would be paginated. There'll be a limit because the message history is really long. We wouldn't want to fetch all the messages. So that's something you can definitely talk about. Also, of course, and the most, I guess, commonly used activity would be like being able to send a specific message within the context of a certain direct message, right? So I'm having a direct message with my manager. We have this conversation, it has an ID, and I can send messages there. I can fetch the messages as well. I think it's very important to stress that in terms of receiving a message, in terms of a user being able to see the latest set of messages, let's say in a specific direct message conversation with their manager, they're not going to be calling our front end app is not going to be calling this get endpoint and just continuously poll. That's not how this MVP is going to work. We're going to do something more real time, maybe with WebSockets. So we'll get to that. So that's why I just want to make that clear. This is just a situation where maybe the user opens the app or refreshes or something. Obviously, you want to fetch all the history. But in terms of if a new message just comes in, there's going to be some real-time based approach for this. So we'll get to that when we do the high-level design. Next, in terms of messages within a channel, right? So again, with channels, we're talking group conversations, and really, this is still related to sort of the channels collection. It's pretty much the same endpoint. So you send a message within a specific channel. Once you know the channel ID, so we have the channels collection, we have a specific channel ID, and then we have messages. So if you want to fetch all the messages in channel, when you've like loaded a channel, maybe you click on a channel and it opens up, right? It uses this data to fetch the messages. Of course, there'll be pagination, some kind of limits to make sure we're not trying to fetch, so many messages that the request takes too long to load, or the app starts crashing because the memory use is too large or something of that nature. Of course, you can send messages in channels, so there's still the same path, right? Next one has to do with threads. So within a specific channel, so we have a channel ID within the channels collection, and we have messages, and we have a specific message identified by an ID. So the idea is this is the root ID of a thread. One can fetch all replies to that thread, so all messages in that thread, and one can send a reply on that thread. So that's what this path is for, dealing with a specific thread within a channel. We are not going to allow the creation of threads within threads. That's just going to complicate things. And as far as I'm aware, Slack doesn't support that as at the time of talking. And the final set of endpoints pertain to do with files. So users can upload files, but also if I could be a recipient of a file. So if the user wants to upload a file, the app is going to have some endpoint to facilitate this. So I'm just going to post some files. I'm not going to talk about the payload. I don't really want to necessarily talk about implementation details when we're laying out the interface. Having said that, I'm going to explore this idea of a pre-signed URL for uploading the file to some data store, but we'll come back to that. So don't worry too much about that. The key thing is we have an endpoint uploading files, and there'll be some kind of useful payload. And as for the file endpoint, when a user receives a message that has file attachments, they would need a way to actually download that file, especially in the scenario where they click on the file and they try to open it. So that download process would need information about how to actually do the download. So download URL. So just provided as endpoint is very simple. So get, we want to fetch, right, a specific file. In theory, we could have something that supports fetching a collection of files, so multiple files, doing multiple file downloads like in parallel. But for the MVP, I'm keeping it simple. So we have an endpoint for fetching a specific file. So this file ID is something that will be in the message that would receive, let's say, in a direct message. So let's say we had a get on a direct message. The response payload would have the file ID if there's a file linked to that message. So that covers all the endpoints, and these are simple enough for a minimal viable product. I've tried my best to minimize to avoid redundant endpoints, to keep things simple. If you have any thoughts of any endpoints you think might be useful, you can leave a comment about that. We've gathered requirements, we've laid out our entities and our API. So now let's get into the meat of things. Let's go through a high-level design. So for high-level design, I usually approach this in two phases. The first phase of the high-level design is just laying out all the relevant services, components, pieces of infrastructure. Not necessarily thinking about how they interact just yet. So I'll just delete this arrow. So if you think of a jigsaw puzzle, the first thing you could do is probably just lay out all the pieces, and then later you start thinking of how they no, but later you start connecting them together. So in this first phase, we can still think about how things are connected. I'm just not doing the connections just yet, at least not fully. So of course, we have a web client of our service, the user on the browser, in this case. And in this design for this MVP, I decided to keep things local to a certain region. So maybe we're just in North America, for example, as opposed to like a multi-region sort of design. So we have a regional load balancer. So the idea would be that traffic from the client sending all the HTTP requests we listed here, the post, get, patch, and so on requests will come in here. So HTTPS request, so S to indicate that it's secure. And what this regional load balancer would do is it will perform TLS termination. So this is a compute intensive operation that we just want to happen once. And the reason for that is beyond the load balancer, we want all traffic to be plain HTTP. So within our sort of private network, with our firewalls enforced, there's no direct access from the public internet. So essentially, any request coming from the public internet is HTTPS and it terminates here. Beyond the load balancer, everything is just plain HTTP. So following the TLS termination, the load balancer will route requests to our API gateway, at least one of the instances. So you can assume we have multiple instances. That's what this times n notation means. So you can let your interviewer know that this just means to have multiple instances. Maybe we can even elastically scale. I don't want to dive into that, and not too interesting. The API gateway would help with rate limiting. It would help facilitate authentication of users. So essentially, what would happen is when a user first, signs up for the service or logs in, what would happen is their requests will flow through to the authentication service. This authentication service would obviously check in their username, password, and essentially, if they are who they say they are, will issue a JWT token, and this would be provided to the user as part of the response of their signing in. So they'll have a JWT token. I think so far we said HTTPS between the client and the load balancer, HTTP between the load balancer and internal services, and then there's this concept of the JWT token. Appreciate some of you might not understand what these mean, at least JWT. This is explained very clearly in the explanation section. The way I'll just, for the purpose of this high-level design, just think of it as a token that whoever bears this token, we will trust is who they say they are, essentially. But that's a very simplified way to go about it. So if a user has a JWT token and any request they send, we will trust that they are who they say they are. But we don't just blindly trust. So first, you think of the first flow, user signs in. We give them a JWT token. Once they're signed in, every other request they send, whether they're trying to send a message, join a channel, read their messages, or whatever they're trying to do, the request they send in the header will include this JWT token. So the request will again flow through regional load balancer to the API gateway. What this API gateway will do is it will fetch a private key from the authentication service. Typically, it will cache this in memory. It can always fetch it again from the service once it expires, or if it loses it for any reason, let's say it restarts, and it will use that private key to essentially perform a cryptographic operation on the request, and it essentially will validate that the user is who they say they are, and if they do, that the JWT token is valid and it's consistent with how it was signed. Again, we don't want to jump into cryptography here. The API gateway will do this for every request. It doesn't have to talk to the authentication service each time. You only need to do that during the login, or if it needs to maybe get this private key, maybe it got restarted, but it'll cache it in memory. And from then on, the API gateway, if it successfully verifies that the users who they say they are, it will then forward the request to the appropriate service, whether it's the chat service or the file service. So for the file service, it's very obvious that this will be responsible for anything involving uploading of files or downloading of files. And the chat service will be involved with all the other endpoints, so sending a direct message, fetching messages, sending a message in a channel, fetching the messages in a certain channel, and so on and so forth. Obviously, we would be performing some form of authorization to make sure that the user actually has the authority to do what they're trying to do. So for example, if the user is trying to send a message in a certain channel within a workspace, we would have to authorize that the user has that permission. So the chat service can also take responsibility for that. Authentication is different from authorization, right? Authentication is just verifying that the user is who they say they are. Authorization is verifying that the user has the permissions to do what they're trying to do. Let's talk through the rest of the component I have. So it'll be easy to think through this if we just pick a simple workflow. So let's say a user is sending a message to someone else, right? So there's a request that gets to the chat service. chat service checks if the user is authorized to send this message, and the chat service will actually persist this message in our persistent store, which is a database. I just put PostgreSQL as an example, but I'm not locked in on this decision just yet. I just need a persistent store that's suitable for relational data, which is kind of what we have. I'll come into that in the next phase of the high level. But for user A to send a message to user B needs to get a notification. So the way we can achieve this is the chat service will actually will essentially publish an event saying a certain message, you know, was sent, from user A to user B. And what I could have is the notification service. Well, actually, the real-time delivery service consuming, it subscribes to the relevant topic. So it consumes this message and actually delivers the message to the targeted user in real time. So whether that's via WebSockets or server send event, I haven't locked that in yet. But the key thing is there's a real-time delivery going on, right? So user B gets the message. Now, user B might be offline as at the time user A is sending the message. So what can happen is also have a notification service that subscribes to message creation events. So whenever a user tries to send a message to a user, the notification service also consumes this message. And what it can do is check if the target user is online or offline. If that user is offline, it can then create a task by publishing to this queue. It's a job queue essentially. I'll come to this later. And this asynchronous workers I have could consume from this queue of tasks and then perform them. So in this case, since the user was offline as at the time the message was sent, the async worker can then say, well, I'm going to process that task. In this case, the task would be to send an email notification. So do that via an email provider. This is an external service. And the reason why we're doing this asynchronously, and by that I mean, I'll come back to that. We're doing this asynchronously for performance reasons, for scalability reasons. And by asynchronously, I mean everything isn't just happening. When a user sends this message, they will get a response because essentially the chat service will do authorization and dump, data in the database, dump the event, publish the event in the event bus, and it's done. It doesn't wait for all the other activities to be performed, such as the actual delivery of the message to user B or the email notification, right? So by asynchronous, I just mean we're not waiting for all these things to be complete. Furthermore, there are situations where I might need to retry some events. So for example, in the case where we did try to send an email notification, so the async worker tried to send an email notification, perhaps this email provider is down or is slow or has an issue, just times out or whatever, we can easily schedule a retry. So the async worker can easily publish a task, back on the queue for it to do a retry. And even after a while, we may have situations where we've tried things, retried things enough times and exhausted the retry limit. In that situation, we would want to, instead of just abandoning the message and giving up, we would want to store it in a dead letter queue. So this queue also helps to serve that purpose. And what would happen with a dead letter queue is a human operator can come in and have a look and decide what to do. Maybe there's something invalid about the message, or maybe, again, an external provider like the email provider is down. So that allows us to handle situations where retries have been exceeded. So we have the persistent store, we have notification service, we have asynchronous workers helping with email delivery, we have the real-time delivery service helping with actually delivering the messages to users in the channels or direct messages. But we also have the object storage, and this is actually where uploaded files will be stored. So whenever a user actually is including a file in a message they're sending, they don't actually transport this 50 megabyte, potentially 50 megabyte file, to the file service, and the file service then stores it in our database. What actually happens, and we'll come to this a bit later, is they will be giving a pre-signed URL, which basically tells them, so by them I mean the client, where to actually upload a file. So they can upload a file to this object storage. It could be like an Amazon S3 bucket, for example. And whenever our backend needs to refer to that file, it can always access it from the object storage. So that reduces latency and bandwidth usage, because if we had to pass this, potentially large file across different hops in our backend, that would be expensive. Also, with the object storage, it allows us to persist these files durably. We can obviously set, for example, the Amazon S3, we can set a lifetime, and it allows us to meet our recovery point objective. In fact, with Amazon S3, we wouldn't have to worry about the 1 minute limit, because once file is stored there, it's going to be stored durably, so we wouldn't even lose that data. So we will meet that RPO. So we have quite a few decisions here that I've made, or I've alluded to making, that we need to justify, right? I've listed 6 of them here. The first one is using JWT tokens for authentication. So I sort of explain how they work. There's a lot of cryptography behind them. So it's an industry standard, but the main reason I actually used it for authentication is because it reduces latency. So when a user signs in, as I explained, the authentication service will facilitate processing the request and issue a JWT token, which send back to the client in a response, and they now bear. And every other request they send, so whenever they send any message, it will have that JWT token in the header. This means that for any other activity they want to do, we don't have to re-authenticate them until the JWT token expires. And that's important for latency, because if for every message sent we had to do authentication, that would obviously incur a performance cost. And this definitely helps us with regards to reaching our latency target, and of course allowing us to actually achieve authentication. So if user A is sending a message to user B and user C, some malicious actor would find it very difficult to impersonate user A, because they'll have to get the JWT token, which it's very difficult for them to fabricate due to cryptography reasons. Even if they were able to get user A's username and password, we could add an extra layer of, we can add two-factor authentication to even add that extra layer of security for extra authentication. So that would help us on the security side of things from our requirements. So yes, we could even add two-factor authentication. For the MVP, maybe that's overkill, but it's definitely good practice. The second decision has to do with asynchronous processing. So I have a lot of asynchronous flows. So let's think of a scenario where user A is sending a message to user B, and let's say user B is not available. Let's say they've stepped away from their desk, right? So let's see what would happen. So in the synchronous flow, when a user sends a message, obviously we have the authentication authorization. Same thing in the asynchronous flow. We can't escape that. And we've agreed that partially asynchronous flow, sorry. And we also agreed that we are going to persist the actual message in database so it's durable, we don't lose it, before we send a response. So we're going to do that in both flows. However, the key difference now lies here. In synchronous flow, so we write the message database, and once we've done that, we then push the real-time update. This means delivering the message to the target recipients, whether it's a single user in a direct message or it's all users in a channel, and also sending notifications, so email notifications if the user happens to be offline. And then returning a success response to the user, or whatever the appropriate response is. In the asynchronous flow, once we persist the message in a database, what we then do is we push an event to our event bus, and that's it. We return a response. So all the other activities, delivery, real-time delivery, notifications, and so on, these all happen in the background. So a user who's sending a request does not have to wait for, in the partially asynchronous flow, does not have to wait for all of these things to complete before they get a response. This means that the time taken to process a single request is much shorter in the asynchronous flow or partially asynchronous flow than in the synchronous flow. This means that in any given time, we can process more messages. So this is good for scalability. For example, if in the synchronous flow, it took 2 seconds to process a single message. I'm just making numbers up. That means in 10 seconds, we'll only process 5 messages. And let's say in the asynchronous flow, which we say takes less time in terms of getting a response, let's say it took 1 second, that means we can process 10. So 2 times more messages in a given unit of time. So you can see how this scales better. The next decision has to do with my need for an event bus and a job queue. So we already established that there is some asynchronous processing going on. So when the chat service receives a message and it persists that message in a database, obviously that message is going to one or more target users. It will create a message created event, store it in the event bus, and we have some consumer services that will react to that. And as part of that flow, some tasks can get created and stored in a queue. And we also have this dead letter queue for tasks which have been retried enough times that the retry limit has been exhausted, and so we need to decide what to do with it, right? Maybe a human operator comes in and replays it manually or makes some fixes or whatever. So I have this sort of depicted here to maybe help with the explanation, but essentially I have two different things going on. I have this idea of an event where I can say something happened. So user trying to send a message, the chat service would publish an event, message created, and the real-time delivery service as well. This event is saying that user A is sending this message to user B, so it delivers the message to user B. And there's also potential consumption by the notification service if that user is offline, and it can send an email notification. But what the notification service does is if the user is indeed offline, it'll create a task and store that in the job queue. So the distinction between the job queue and the event bus is that the event bus is where you indicate that this event happened, and you can have one or more consumers who react to that. A job queue is more suited to a situation where you have a task which you just really want to be performed once, and you want to facilitate retries. So maybe a worker consumes the task, tries to perform it. If it fails, it has the ability to retry because the task isn't really acknowledged until that task is completed. And if we keep retrying and exhaust the retry limit, we have a dead letter queue. So this idea of an event bus and a queue kind of serve different purposes. Queue is more for, I want this thing to be done, typically once. And event bus is just saying this event happened, whoever cares, do whatever you want to do with it, right? So that's kind of what we have depicted here. This is for the job queue. This is my event bus. The question is, what do I use to store these events or these jobs? And I have this decision matrix here. So a lot of people have heard of Kafka, RabbitMQ, Amazon SQS. I've actually decided to go with Redis. I have this bull MQ here. I'll talk about this a bit later, but we think it's just about Redis as being the store for the events and the jobs. I'm actually going with that for the MVP. The main reason is because of its low operational overhead. Green just means excellent. Blue means good. So Redis and SQS, I guess in this case, have low operational overhead. So they both tick that box. But in terms of durability, Redis isn't so great. So I'm actually making a trade-off by making this decision. So for low operational overhead, I am going with Redis, but I have to pay the price of durability. And the reason why I'm okay with this is because even if any event is lost because Redis crashes for some reason or any task is lost, these tasks, the implication of this is maybe a user doesn't get a message or a notification. Well, if they refresh on the browser, they would send a request to get all their messages in a certain direct message convo or a channel. So it's not like this messages are lost. We have this backed by our persistent store. So for the purpose of the MVP, it's not so much of a big deal. Looking at this table, one can clearly see RabbitMQ and Amazon SQS, take most of the boxes. Green is excellent, blue is good. And this relative to Redis, Kafka is clearly the worst here. The other reason why I'm still insisting on Redis relative to these two is because this is an MVP. I would like to minimize the components or infrastructure pieces I have to reason about and deal with for the MVP. I already know that there's a good chance I'm going to need a cache. And if I already have Redis, meaning I have a cache and I have my event bus and queue all in one, that means, I get more bang for my buck. That versatility of Redis is going to be very useful there. And just even looking at, our flows, just say someone's trying to send a message and the chat service is processing the message. One of the things it will do is check, okay, whoever's trying to send the message, do they have the authorization? We spoke about authorization checks, right? To send a message in a certain channel or workspace and so on. And that kind of information, is something that we could cache. So we can store in the same cache and do a quick lookup instead of having to read from a database, which is slower, right? And that can improve throughput performance. So that's why I'm going to stick with a cache. Obviously, you could decide, to go with one of these two and have a separate cache as well. That's up to you. But I'm just going to put everything into one. So I've updated the diagram to also add the cache. So essentially, this whole box I have here is kind of depicting quite a few things, and Redis is allowing me to do all these four. So the versatility is really just why I'm doing it, and it makes life simpler, all in one. The next decision we need to justify is the choice of a real-time delivery mechanism. I've decided to go WebSockets, and I'll explain why. I have prepared this table that has a comparison of three options: WebSocket, server-side events, and polling on different criteria. We can already see polling doesn't look too good. Feel free to look at this offline and dive deeper. But I'll use this sort of cartoon to justify my decision, and so that's easy for you to follow. So with polling, the key issue with polling is it's very inefficient. So we could have, for example, the situation where the user polls the backend, saying, do I have any new message? Do I have any new message? Do I have a new message? Do I have a new message? And then at some point, if they do have a new message, the backend says, well, you do, and returns that message to them. The issue with this is it's very wasteful. Um, you know, for example, if we decided to poll every 5 seconds, one apart from the wastefulness, one issue is that then a user would only get updates every 5 seconds, which isn't good enough for our real time requirement, right? You get a new message and then it takes 5 seconds to receive it. That's too long. If we decided to reduce the polling interval from 5 seconds to every 1 second, so we poll even more wastage, right? Even though now the time a user waits to get an update is shorter, there's still a price to pay. So polling is just inefficient. I'm just going to rule that out. Which leaves us with these two options: server-side events or WebSockets. Both of them are actually reasonable and would work because they allow the backend to send a message, like stream a message to the user. So as soon as a user receives a message, the backend can just let them know straight away. So that's great. However, the reason why I opt for WebSockets is when I think of the future and how this app will evolve. Like the effort to set up server-side events and WebSockets is not too radically different in this day and age, especially with AI-enabled coding and so on. So the reason why I'll go WebSockets is that in a future iteration, I may want to build on what I have. So an example would be I may actually need bidirectional communication. So if I just cared about server being able to send to user, both of these work for the MVP. But if I decide I actually need some features that require the user also being able to communicate with the backend on that same persistent connection, then WebSockets win. So for example, if I wanted to add a typing indicator, so this is a conversation between two people and one of them is typing, right? There's this typing indicator. With WebSockets, the user, in this case, that will be Arjun, will be Zoe, can actually send a sort of signal indicating that they are typing. So whenever they type in, their client can send a signal to the backend saying, actually, this user is typing. And that can be fanned out to whoever they're talking to, if it's a direct message or If it's a channel with multiple users, they can also all see this typing indicator. So that's just one sample feature. There's others. So WebSockets definitely. The penultimate decision is this file storage location. So I'm considering two options. One, which I really hate, is if I had to uh, store files in my persistent store. So if a client wanted to upload a file, they'll send that file through, and eventually one of my services, maybe my file service, will then persist in the database, which means a large amount of data is hopping through, through different uh, layers of my application. I would say that's one, slower, and there's just more of a headache in terms of maintaining my database. Whereas we have these object stores like Amazon S3, which is really optimized for this use case. And when a client wants to upload a file, all I have to do is send them a very light message that says, hey, here's this URL of where you should kind of upload the file. And all they have to do is just transfer the data. And these object storage are very good for parallel downloads and also uploads. So they support that. They'll be good when we intend to scale. So it's going to be a good choice now for the MVP and the future. So I'm just going to go with that. And the next decision has to just do with our persistence layer. And I've decided to go with PostgreSQL. I think any decent relational database would work because the data we have is very relational. So workspaces, well, channels belong to workspaces, users belong to workspaces and channels, users have roles, and so on and so forth. So it just works naturally for the kind of data I am going to store. That's one reason. In addition to relational data naturally fitting well into PostgreSQL, let's consider a case where a user sends a message with a file. So they're sending a message to someone else and there's a file attached. What would happen is at some point, that message will get stored in a relevant message table, but also the file which would have been uploaded to our object storage, the metadata for the files. For example, it's the URL to download the file will be stored in our database as well. And I would want to do that in a transactional way where if I am persisting that message, so the text, for example, and then the file that's attached, I want to do that in one transaction in an all or nothing situation. I don't want a situation where I persist the message and then essentially, the real-time delivery service notifies, the recipient that they have a certain message, and then they try to access the file in that message, but my database happens not to have the path to the file. So that would be annoying because of a lack of being able to do things in an atomic way, all or nothing. If the message has a file, I want to persist details about the message and the file before I notify the recipient that they have this message and allowing them to sort of access it. That's the second reason. The third reason is it's obviously suitable for the MVP in terms of being able to store what I'll say relatively small amount of data we're storing. But if even in the future when we decide to scale, PostgreSQL is good enough because we can horizontally scale. We can have more read replicas if we want to optimize read throughput. We can partition our tables if they get too large. So we have a lot of room to grow. Now, to conclude, especially if you have time in an interview, you should definitely try to do deep dives into at least one area, potentially more. My recommendation is that you present a menu of areas you think are worth diving deep into. So for example, I have 5 areas here. So talking about how okay, I'll summarize them. The chat service right path, how real-time delivery works. You can dive deep into the data models of our PostgreSQL database and indexes, how we handle fault tolerance, how notifications work. We've kind of covered all of these at a high level and in some areas with some depth, but just this whole coherent end-to-end flow in each of these areas is a good thing to do. But the thing in interviews is sometimes an interviewer has things they particularly care about and are looking for. So by presenting a menu of options with them, you've shown some effort, you've shown some thought, and you can just check with them, is there anything you'd like me to talk about? If it's something on the list, then they'll point it out. If it's something that's not on the list, they might just indicate that to you. And then you can, keep diving deep till you run out of time. But you should only do this if you, at this point, you've actually shown that your design satisfies all the functional and non-functional requirements that we gathered in the beginning. So this video is getting a bit long, and what I'll recommend is you have a look at the tutorial on the site. It dives deep into each of these areas. So for example, for the first one with the chat service write path, it just walks through what happens when a user sends a message and how we are using role locking to avoid sort of race conditions. So for example, if a user is a member of a workspace, as at the time they're sending the message, and we have a lock on the row, the membership row, or the row in the database that has information, the reason why we lock it is we don't want a situation where the user's membership gets changed, whilst they're trying to perform an action, right? Maybe once you're done with the message you're trying to send or whatever they're trying to do, then the ability to update their membership, maybe remove them from a workspace or channel, or alter some permission, can be done. And then, how the message gets parsed in case there's a user sort of mentioned. So if you use Slack, you can mention a user, and that can result that to a user ID, how the message gets stored in our database in a very transactional way. If the message has a file, we also make sure we do, you store the metadata for the file in that same transaction. And, we do this in a very atomic way on commit. And, this ensures this message is durable. And then, of course, there's the flow of how the message gets delivered to the recipients, which is pretty much another area to deep dive into. But the key thing is, we just publish to the event bus and return a HTTP 201, created message. Just means the message was created, so success. So there's other areas deep dive into. We want to also dive deeper into why we use lock membership and exactly how we do this, including isolation levels. So that's something to look at. So definitely explore the areas to deep dive into, as many as you have time for, and it should be easy to follow. If you found this video useful, you think we should do more, if you have any topic you think that we should focus on, just leave a comment in the comment section. If you have any thoughts on things you do differently, share your thoughts in the comments. Be sure to give us a like, hit subscribe, and see you in the next one. We're going to try to ship out more videos, and I'm going to try some alternate styles where, for example, we might actually do, instead of this tutorial style I worked through today, we might actually just do a simulation of a real interview between a candidate and an interviewer, and then we'll also have a tutor that jumps in to just clarify things. So that's another style I'm going to go for, and hopefully that would make things even easier to understand. Be sure to check out our coaching and mock interview service. You can get paired with an experienced engineer from big tech. We have a lot of testimonials. We've helped a lot of people level up, get interview ready, and land offers at their target companies. So definitely explore our site, as well as our learning courses. There's a lot of free resources here. Check them out. Should help you in your journey. See you in the next video. And be sure to hit that like button and subscribe.